Hello, welcome to revision tips for CIPS Level 4, Diploma in Procurement and Supply. This is Module 2, Defining Business Needs, and it's Learning Outcome 3, which is to understand the use of specifications in procurement and supply. So we're going to look at the different types of specifications, and let's start with the performance and conformance. So specifications are an integral part of procurement, and I often refer to them as the heart of the contract. And there are two types of specification: performance, also known as outcome focused, and conformance, which are also known as technical. The performance specification outlines what the product or service is to do or achieve, which allows for a little bit of innovation. You can see various options on a requirement that can be considered, and it promotes innovation and competition within the marketplace because you're not tying them down to what they need to supply, just how it needs to achieve a function or how it needs to perform. So it is often known as an output or outcome-based approach, and we use it in things like facilities management. So maybe at the start of a cleaning contract that an office should be kept free of rubbish. So how they do it is up to them. So it's about the what, not the how. Conformance specs or technical specs details exactly what the product or service will be made of, like a recipe. So it focuses on the inputs. Responses to a conformance spec should have identical offerings. So you'll often see it used in pharmaceuticals and agriculture. And you may identify specific manufacturers or components, and what it does is it ties the supply to a set detail. Performance outcome-based specifications are usually used on services, whereas conformance or technical ones are usually used on products. So on the screen, you can see the key sections of a specification. The scope, the definition, the description of the requirement. What will testing and acceptance look like? How to make changes, and any social or environmental criteria. But if you look at the definition, this defines the user requirement. Now, errors or lack of clarity at this stage can result in problems in delivering through life management. So when drawing up a specification, a definition for a through life specification is to produce something known as a user requirements document. And you ask open-ended questions like, what is this product or service for? Who will be the users of that product or service? And what problem will this solution solve? It just makes sure that the functions and attributes, constraints and preferences and expectations of a product are fully explored, and any trade-offs between them are agreed. There should be sufficient information in the specification to allow the contractor to quickly and accurately develop a price for the product or service and to minimise risk later in the life of the contract. The description is determined by the type of specification. So we know that a conformance spec will be precisely setting out the instructions to which a supplier must conform. But an output spec will consist of a description or clear functions that the performance is required. It will have a broad description of the end result and a vision for delivery, focusing on the need of the user to prevent the list getting too long and unmanageable. In terms of testing and acceptance, it's used to determine whether a product meets its specification before it's released to the customer. So you're probably going to ask questions like, did we build the right thing? Is this what the customer really wants? And it may involve physical tests like chemical tests or performance tests. And if the product or service meets the standard, then it's passed as suitable. If not, it's rejected and corrective action will need to be taken. Change control just looks at the mechanisms and remedies. And the environmental and social factors, well, the environmental factors will look to minimise the impact on the environment by recovery from natural disasters or management of waste emissions, pollution and energy efficiency. The social criteria is the way the organisation seeks to protect and empower the local workforce and communities. So, for example, by paying a living wage, providing suitable working conditions and so on. Now, all relevant stakeholders need to be involved in defining the requirements. The clearer you can be to communicate the requirement, the more likely the supplier is to meet or exceed your needs. Without an effective specification, how will you know you're being supplied with the products you need? It's interesting to compare with what Lyson and Farrington say their specifications should aim to do. They say it's indicating a fit for purpose or use, communicating the requirements of the user, and a company that is actually supplied with the requirements in terms of purpose, quantity, and performance as stated in the specification. Providing evidence in the case of a dispute. So here are some of the issues relating to contracts that help us understand the importance of specifications. Now, contract law requires suppliers to conform to any specification of requirement that's included in the contract. And it must be supplied as satisfactory quality, and fit for purpose. If you can take a few minutes to research a UK law case, it's Moore versus Landover of 1927. This will help you to understand the advantages of the specification. So in terms of fit for purpose, the buyer tells the supplier of the purpose of the goods that will be used for. So for example, if I specified a 5-drawer lockable metal filing cabinet, I would say the cabinet is being bought to store a number of documents that will not fit into a 3-drawer cabinet. A lock is needed because the documents need to be kept secure, and a metal cabinet needs to guard the documents against any potential fire damage. If this was communicated to the supplier in the specification, we could then reject a 3-drawer wooden filing cabinet with no lock if that was what was delivered. So effective specifications remove any doubt, ambiguity, or misunderstandings in the supplier's mind as to what the purpose is and what constitutes satisfactory, quality, and fit for purpose. So I would say the process is very useful discipline. It provides that criteria of measuring the quality and can be used in evidence of a dispute. But what about the disadvantages? It can be important to consider how to overcome some of the disadvantages. So for example, approval processes that will prevent over-specifying, building relationships with supplier that will encourage innovation. So the disadvantages are that detailed specifications is an expensive and time-consuming process. Then you've got the cost of inspection, quality control. They can become too firmly embedded, which means that the supplier won't allow any flexibility. They can create a temptation to over-specify, adding cost, and can curtail innovation from a supplier's point of view. Now, the International Organization of Standards provides a wide range of standards, so the ISOs. Standards are measures that show the expectations that are set out in a specification that have to be met. They include, for example, the level of performance of a machine, the quality of the materials used, or safety levels in food and drink. Now, CIPS suggests that it can be a good idea to get suppliers' views on complex specifications, and it's often in form of market testing or market sounding exercises. So early supplier involvement can bring about process improvements, supply chain improvements, and a reduced supply risk. But do remember, suppliers may be biased in their own favour, and there are strict rules about early supplier involvement in public sector organisations. Moving on to through-life contracts. So through-life contracts are just what they say they are, contracts applicable throughout the life of an asset. So they're common when you're producing an asset such as machinery or IT equipment, and they're needed to support the purchase of the asset and the continuing services that support the installation, operation, maintenance and disposal of that asset. The type of support will change, and may be offered by different departments and personnel. But what they have in common is that according to CIPS, all of the activities require a specification and need to be within the scope of the through life specification. Now, if you're not clear what it is you want, how can you expect a supplier to provide it? This is compounded with through life contracts, when those requirements may be provided by different suppliers' departments as they change over time. So it may be helpful to think of the term, if you aren't clear about what you want, how are you likely to get it? CIPS state that the first and most critical step in producing a through life specification is to define the user requirement, and that many problems in delivery through life management stem from an unclear requirements definition. So here we can help with, I suppose, ensuring that a common understanding prevents misunderstanding, which can in turn result in time and effort being wasted, or worse, defective products that can cost life. An acronym or an abbreviation that is formed from the initial letters of the words can be pronounced as a word. The imperative is used to give orders, command, warnings, or instructions. So once user requirements are understood, the time has come for you to actually write the specification. And CIPS offer the following advice. Use simple language in short sentences. Define the acronyms that you use. Avoid abbreviations and be specific, avoiding ambiguity. Use imperative forms of language where possible. Now, if changes aren't controlled properly, the final product or service could be different, much more expensive, and less fit for purpose. Constant changes that are not necessary and yet take a great deal of time and effort can also be frustrating for the suppliers and damage the relationship. So in a moment, we'll look at the typical processes for identifying and approving changes in the specification. But the remedies and mechanisms is that, they can change for a number of reasons, but will add extra cost and time. So you need to make sure that the change process is followed and carefully evaluated and approved. Change is inevitable during the delivery of any contract. So stakeholders change their mind, or, new regulations are introduced or new technology is released. Change management or a change process is a way to authorize and make changes, but without so many changes that the deliverable gets derailed. So steps in the formal change control process is firstly to describe the change and the reasons for that change. Secondly, include the impact it will have on the project timelines and the difference the customer will see. Review and discuss the change with the whole project team to determine if it will be accepted, amended, or rejected. Document any options for the proposed change together with the data that supports that preferred change and the options that were put forward. And then formally approve or reject the change with input from key stakeholders. Any approved changes are then incorporated into a revised specification and updated project plans. Now, some of the reasons for drafting specification can be seen in the principle of specification writing that's identified by Purdy and others, that's cited in the Lyson and Farrington book of 2016. So if something is not specified, it's likely to be provided. Every requirement increases the price. The shorter the spec, the less time it takes to prepare. And the spec is equally binding on both the purchaser and the vendor. The spec should, so far as possible, be presented in performance terms rather than in detailed design. And they should, wherever possible, be open, not closed. And they mustn't conflict with any national or international standards or health, safety, or environmental laws and regulations. So make sure that you're clear and unambiguous about what you're requiring. Be concise and comprehensive and compliant with any of the laws and regulations around health and safety in the environment. Make sure it's kept up to date and expressed in terms that are understood by all the key stakeholders. And it needs to be value analysed. We'll talk about value analysis in a moment. Now, you need to sort of think about identifying risks in a specification as well. And the process for identifying the risks is to identify them, assess them, control them, and then monitor them. If we just ask someone to paint our living room, we can't complain if we don't like the colour. That basic principle applies to specifications. So inadequate specification is if it isn't clear what is wanted, we're unlikely to get it. If it isn't clear what is wanted, it may work but may be unusable, and we may incur additional costs and waste time. And as we noted just now, inadequate specifications can lead to a waste of time and money. But that may not be the only term of incurring additional cost. It could be in terms of the product or service not being fully utilised, and to take it to extremes of unsatisfied customers who may move their business to another supplier. So CIPS identify 4 main risks. The product or service is unsuitable to meet the user's needs, wasted money, or the customer needs are not satisfied, or higher cost. But overspecifying has the potential to cost more as things are requested that aren't really needed. Overspecification can also unnecessarily reduce the number of suppliers that are available. Unnecessarily because others may be able to offer the actual requirements, but not the requirements as per the spec. The more complex the specification, the more difficult it is to evaluate. So again, CIPS identify 4 main risks. Greater expense, poor competition, few offers that supply the range of features, which makes it more difficult to evaluate. Misinterpretation can result in needs not being met and increased costs. There may also be additional time involved with putting things right. The ways of mitigating misinterpretation can include clarification sessions, feedback, and piloting. So, misinterpreting needs. When we discuss drawings, we refer to the need to be specific. Being specific should prevent misinterpretation, which can cost time and money. Standardisation can be implemented at 3 levels: product, processes or production, and parts. Product standardisation is no variations which result in longer or unbroken production, reduce costs, reduces the complexity of the operation in terms of production process for products or services, and it helps to improve quality as there are fewer products and fewer components to deal with. But the process or production method of standardisation allows batch production or even continuous manufacturing, which reduces the unit cost of a job shop. Part standardisation reduces costs of manufacturing and logistics, which increases the flexibility of manufacturing operations and delivery times to customers. It frees up people to focus on more value-adding activities rather than spending time on activities like inventory management. The zero-based approach starts with nothing and only adds in parts that are needed. And standardisation at 1 or more of these levels can result in cost reduction through purchasing leverage, reduction in inventory, improved quality and flexibility and responsiveness. And in service industries, standardisation can help to achieve a lower cost and higher quality of service to its customers. So just to reiterate, CIPS identify 3 levels of standardisation in product manufacturing: on individual parts and components, the end products they're used in, and the processes used to make them. Lyson and Farrington list the following advantages of variety reduction: reduction in holding costs for stock. The more you standardise, the fewer processes you have to run with, which in turn is the number of production lines, equipment needed. It releases money that's tied up in stock, easier specifications when ordering, a narrow range of inventory and a reduced supplier base. And Anderson cited in CIPS, but also refers to flexibility and responsiveness. It was Henry Ford, founder of the Ford Motor Cars, who was alleged to have said when the companies first began producing cars, that customers could have any colour they wanted, so long as it was black. While we now want choice, manufacturers understand the benefits of standardising products as much as possible. So, for example, using techniques such as fascias to enable different functions to be used, even though all products have contained functions. Then economies of scale can come from a number of sources. So time saving, bulk buying, they will also come from learning. Now, CIPS refer to the learning curve, a concept that's shown how the unit costs reduce the greater the number of units that are produced. And they emphasise how the concept applies to services. So if you produce a standardised product, it can bring economies of scale. That will result in a number of factors, including accumulated learning, and manufacturers will aim to standardise as much as possible. Do take a broad look at where standardisation can be applied. Hospitals can benefit, for example, from standardising the types of disposable gloves they use. But it may not always be easy. To continue with the glove example, in some situations, high-ranking personnel may have a strong preference. But that doesn't mean that standardisation shouldn't be implemented. Standardising parts can also offer cost saving, time saving, and flexibility. Now, target costing is a common way to identify the costs associated with an activity. The four-step process says decide the selling price the market will accept. In any industry such as healthcare, construction, and fast-moving consumer goods, it's so fierce that sellers become price takers rather than price makers. Decide the minimum profit levels that is acceptable. Take the profit from the selling price to arrive at a target cost. And then start a project to identify ways to reduce the current actual costs to the target level. Okay, value analysis is next. So this is a function that refers to what a part is meant to do. So Lyson and Farrington give an example of a pen, the function of a pen being to make marks. Value is the context as defined by CIPS as the relationship between the benefit something brings and the cost. So value analysis can enable the same benefits to be provided at the lower cost, thereby increasing value. More benefits to be provided at the same price is another way to look at it. Again, Lyson and Farrington state that value analysis results in the orderly utilisation of alternative materials, newer processes, and the abilities to specialist suppliers. So as you can see, it focuses on identifying any unnecessary costs, especially ones that should improve value. So therefore, the value analysis are functions and value. Value analysis is done, by the way, to a product that's already on the market. So it's sort of at the maturity stage of the product life cycle. Value engineering, on the other hand, is done before the product's ever launched onto the market. So the Kano method is focusing on delighting customers without adding undue costs. So delighting customers is an important term, especially when you're gaining customer loyalty. It's generally considered more effective to retain existing customers than to keep acquiring new ones. Each of the requirements you see on this screen can be seen in more detail. If you look at YouTube, there's loads of videos on value engineering. But the Cato method identifies 5 types of requirements: attractive requirements, one-dimensional performance requirements, those that are mandatory and indifferent, and those that are reverse requirements. Now, CIPS reminds us that writing a specification is a team activity that involves a number of stakeholders, and the role of procurement is to engage and advise the stakeholders. There are 4 key steps. First, identifying who your stakeholders are. That's the first step. Then understand and prioritise them. Prepare a plan to engage them, and then implement the plan. So an approach can help prioritise stakeholders is the Mendelow's matrix. Now, this is a way of mapping stakeholders according to their power and influence on the organisation, or in our case, a specification. So we can begin to categorise stakeholders as requiring minimal effort, those that need to be kept informed, those that we need to keep satisfied, and those that are our key players. See, category A's are the ones with neither power nor interest. B's, those that have high interest but don't really have any influence. C are the ones with high influence, low interest. And category D have the greatest and largest amounts of interest and influence. Thank you for watching.